Welcome to the debate. So we're seeing this really fundamental strategic split emerging in how AI gets operationalized within the enterprise, right? The decision for, well, pretty much every organization boils down to this. Do you bet on maximizing that general cutting-edge performance, which, usually means adopting the biggest proprietary models out there? Or do you prioritize control, cost efficiency, and maybe specialization through open source frameworks and these increasingly sophisticated agent systems? That's really our central question today. And I'll be arguing strongly for, let's say, continued reliance on the most capable general-purpose proprietary models, simply because their superior raw performance and, frankly, their seamless multimodal capabilities are what fundamentally push the frontier of what enterprise AI can actually achieve.
And, well, I come at it from a slightly different angle. Well, yeah, the raw capability of those frontier models it's undeniable. I think the better strategic investment, especially for operational scale and long-term sustainability, lies in prioritizing those open source models, the specialized dedicated models, and these increasingly sophisticated multi-agent frameworks. My focus is really on the crucial advantages these systems offer. Things like operational control, drastically lower costs, deep customization, and, critically, transparent auditable governance, which, let's face it, is non-negotiable in complex or regulated settings.
Right. My position, it's really founded on the output ceiling, For any organization that's tackling high-complexity tasks or truly general tasks, the kind that require abstraction, reasoning, synthesis, the current proprietary frontier models are, I'd say, indispensable. The industry benchmarks consistently demonstrate this gap. We see models achieving the highest scores on standardized reasoning metrics like MMLU, GPT 4.1 hitting an impressive 91.2%, and in critical high-value areas like coding, while Claude 3.7 leads the pack with 70.3% on SWE Bench. These closed systems, they consolidate power and versatility in ways that, custom, smaller models they can't replicate right now. And beyond just text, the multimodal revolution, that's happening almost exclusively within these massive proprietary systems. I'm talking about the seamless integration of text, vision, audio like we see in GPT 4.0. This allows the proprietary model to serve as a single, incredibly capable brain for the most advanced agentic capabilities. Think about the implications of agents like OpenAI's Atlas browser agent, something that can observe the web, reason, and execute complex multi-step actions across various applications. That level of sophisticated integrated intelligence relies, I believe, entirely on the general cutting-edge capability of the proprietary platform. It simplifies the technology stack quite dramatically.
Okay, that's a compelling argument for the, let's say, highest theoretical ceiling. But I would frame this discussion around strategic enterprise investment, well, differently. While raw benchmark scores are impressive, yeah, they are often poor proxies for real-world strategic value. The true ROI, I think, is derived from systems that offer organizational control, absolute data privacy, and superior efficiency for specialized, high-volume tasks. Benchmarks like MMLU or GPQA, they measure generalized knowledge, sure, but they aren't reliable indicators for specific enterprise needs. We really need task-specific evaluation. And this strategic necessity, it's one of the core findings in leading analyses like the State of AI Operationalization Guide, which I'll probably just call the SOA Guide, which really emphasizes operational readiness over just generalized performance. And when we shift the focus to efficiency, the advantage swings, dramatically toward open systems. Just consider the economics for a second. Open source models like DeepSeek V3 are priced around, $0.27 per million input tokens? That drastically undercuts proprietary counterparts, which can hover near $10 per million tokens for their, highest-end general models. As the volume of internal AI tasks scales, and it is scaling exponentially, that cost differential isn't just incidental. It's pretty much the definition of long-term economic sustainability. Furthermore, when tasks require collaboration or systematic rigor, these multi-agent frameworks excel. For instance, the Malia framework, that's a multi-agent architecture, it demonstrated that structured collaboration, including dedicated agent roles like an ethics advocate, achieved an 87.5% recall rate for eliciting ethics requirements in a, pretty complex case study. This kind of high precision, specialization, and efficiency, that's what actually drives strategic advantage, not just the highest MMLU score on a leaderboard.
Okay, I see why you emphasize cost and customization, but let me offer a different perspective on the foundational value proposition here. When we look at metrics like GPQA, we aren't just measuring rote memorization. We are measuring foundational, graduate-level knowledge and complex abstract reasoning. A model like OpenAI's O3 achieving 87.7% on GPQA, that speaks to an underlying intellectual superiority that provides robustness and, versatility. While a fine-tuned, specialized model might win on one niche, isolated task, sure, the sheer power and the generalized knowledge base of the frontier models mean they can handle the unforeseen, complex problems, the strange edge cases and novel demands that define high-value enterprise challenges. Investing in the highest general capability, I think, secures flexibility for the future.
I'm sorry, but I just don't quite buy that the generalization inherent in MMLU or GPQA translates directly or reliably to production operational performance in these niche enterprise scenarios. You're essentially paying a performance premium for capabilities you might never actually deploy. The reality of LLM benchmarking is, highly problematic, as the SOA guide itself repeatedly points out. Models are constantly tuned to those leaderboards, right? Creating an environment where the benchmarks themselves become less reliable indicators of genuine reasoning power. Even qualitative methods, like the chatbot arena, they're flawed, sometimes rating a model better simply because it responds faster, irrespective of the quality or, importantly, the safety of the output. For critical enterprise functions, we simply cannot base our decisions on subjective preference or generalized scores.
We must design specific evaluation criteria that align precisely with the business goal, incorporating rigorous metrics like precision and recall, not just generalized accuracy. Look, if a highly dedicated, focused ML model can deliver superior specialized performance, hitting the required precision targets, with implementation costs maybe 65% lower than adopting a massive general-purpose solution, why on earth would a CIO pay a massive recurring premium for generalized intellectual superiority they don't strictly need for that specific workload? That's not a strategic investment. That feels more like an IT luxury.
Okay, that brings us neatly to architectural efficiency. And frankly, I think we shouldn't get too bogged down in architectural debates when the primary strategic goal is maximizing immediate utility and, cutting-edge capability. The utility of models like Gemini 1.5 Pro with its massive 1 million token context window, it fundamentally changes the nature of long-tail tasks. I mean, imagine digesting a year's worth of quarterly reports instantly for a compliance check. The benefit justifies the expense in those cases. Furthermore, I think you might be missing the velocity of the cost curve here. Inference costs are dramatically decreasing across the board for all models. Industry analysis shows that the price per token to achieve an equivalent MMLU result has decreased, dozens of times over in under 2 years? Focusing too much on cost savings today might mean intentionally settling for lower performance, when tomorrow, that highest performance could well be affordable anyway.
Well, that reduction in proprietary costs is certainly welcome, but it entirely sidesteps the fundamental engineering reality that dictates scalability and, frankly, democratization. You really can't ignore the architecture because architecture determines the cost floor and the scalability ceiling. The traditional transformer architecture, which, let's be honest, underpins most of the proprietary frontier models, it suffers from a quadratic scaling bottleneck relative to context length. That means if you double the context you analyze, the cost and computation requirements literally quadruple. That's a major hurdle. So if we are looking toward the future of high-volume, cost-effective agentic systems, which, you yourself acknowledged is the next frontier, We need linear scaling architectures, and this is precisely where open source innovation really shines. Innovations like the sparse mixture of experts, or MOE, architecture, popularized by models like Mixtral 8x7b, they drastically improve efficiency by only activating a fraction of the model's parameters for any given task. And even more revolutionary, perhaps, are state space models like Mamba, which scale linearly with context length. Linear scaling is an absolute game changer for running millions of concurrent, long context agents, without resulting in the prohibitive operational costs that the quadratic scaling of proprietary models inevitably leads to. These open architectures, I believe, define the path towards sustainable, enterprise-wide AI agent adoption.
Okay, I acknowledge the theoretical efficiency benefits of linear scaling, but the proprietary vendors are clearly leading on integration and, importantly, safety, which is paramount for high-stakes deployment. For regulated industries, partnering with established proprietary providers offers critical layers of enterprise-grade security, uptime SLAs, and integrated safety infrastructure. I'm thinking about services like Azure OpenAI, which provides Azure AI content safety tooling right out of the box, or the reported high safety alignment of models like Claude 4 Opus. It is just exponentially simpler for an organization to manage compliance and mitigate general security risk by leveraging these mature, integrated safety nets provided by established, accountable partners, rather than, having to stitch together security tools around a decentralized open source framework.
See, I'm not entirely convinced by that line of reasoning, because it sort of implies outsourcing responsibility. And the ultimate responsibility for managing risk, especially related to bias, fairness, data privacy, always lies squarely with the organization deploying the AI. This principle is very clearly articulated in the SOI guide, among other places. This regulatory burden demands transparency, right? Into the training data, into the model architecture itself, which proprietary black box models simply failed to provide. How can you possibly audit for subtle bias or ensure compliance if the mechanism itself is completely hidden from view? Open source models offer complete transparency and the ability to conduct deep analysis to verify privacy and reduce bias, importantly, eliminating platform lock-in. But the key differentiator here, I think, is the power of agent frameworks. Using structured multi-agent systems like that Malaya framework I mentioned allows organizations to implement explicit, auditable ethical checks and balances directly within the automated workflow. You can literally mandate an ethics advocate agent role that scrutinizes the output or the requirements based on defined principles, transparency, fairness, data privacy, before deployment. You gain a systematic, verifiable level of control and auditability that is simply impossible when you're using a closed, monolithic system that maybe provides only post hoc filtering.
Right. This discussion really does reinforce the primary trade-off, doesn't it? While efficiency, cost control, and transparency are, undeniable benefits of the open ecosystem, the highest level of raw performance, particularly for complex, multimodal tasks, and that cutting-edge reasoning, the ability to execute highly general and advanced agentic actions like that Atlas browser agent example, that still remains exclusively in the domain of large proprietary models for now. These vendors offer integrated state-of-the-art capability platforms that, provide a single point of failure perhaps, but also a single incredibly high point of performance. And the premium is often justified by the complexity of the problems you can solve today, not, 6 months or a year from now.
So, the core disagreement rests squarely on how we define better strategic investment. For high-stakes, specialized, and high-volume enterprise tasks, I maintain the smarter long-term strategy must favor control, lower operational cost, and enhanced ethical rigor. And that path, I think, requires leveraging specialized, open models and sophisticated multi-agent frameworks to build transparent, auditable, and economically sustainable systems tailored precisely to regulatory requirements and task-specific domain knowledge. The goal isn't the highest generalized score on some chart, but the highest reliable performance for the specific job at the best possible cost.
So the decision, ultimately, it's not just about raw capability versus cost. It forces organizations to really align the technology's architecture, its governance model, with their specific risk profile. their long-term economic realities, and, well, the very complexity of the problems they are actually trying to solve.